Okay, welcome to this week's Megaport Live Tech Drop-In. The topic for this week is ExpressRoute QinQ, or subtitle Azure Single Peering VLAN, which is the associated setting in the Megaport portal. Basically, what we're going to talk about is probably one of the most common stumbling blocks or most common questions that comes up with customers provisioning ExpressRoute connectivity, and that is how the tagging works, how the VLAN tagging works. So Microsoft do some tagging and Megaport do some tagging, and you sometimes have multiple levels. And there's some settings around that as well. So that's basically what we're going to look into this week. So as usual, we'll do a bit of a very quick kind of intro to set the scene a little bit about Megaport and network as a service and where this fits in between the customer's equipment or other clouds or whatever it happens to be and Azure. And then we'll have a look at the actual ExpressRoute circuit itself and the parts of that, what makes that up. And then we'll dive into a little bit more detail about how the tagging works and the different peerings that are configured on that and where this complexity comes from, and then basically how we solve for that, because it's way easier than it sounds. Really, is the message. So Megaport's a network as a service company. We provide network services. We run a very large global private network, and we provide access to that network in the same kind of way that cloud providers provide access to compute and storage resources. So we try to do for networking what cloud providers do for compute. So contrary to traditional telcos, it's on demand, it's scalable, it's elastic, it's API driven. You basically can build out whatever kind of resources you need on top of this network, use them for however long you need, tear them down, change sizes and things like that. You can use infrastructure as code. You can use all kinds of automations and things like that. It's really trying to make the network resources that you have for your global network, maybe global, maybe local, fit that same kind of model as cloud providers, right? So it's, no long contracts, no long lead times. It's all available on demand. It's all able to be automated and orchestrated in the same way you're used to with cloud services. So one of the big outcomes for that, one of the big use cases is customers using Megaport to connect into the public cloud environment, so into Azure and AWS, Google Cloud, Oracle Cloud, so on. And we do that via the cloud provider's private connectivity services. So for Azure, that is ExpressRoute. So basically what that looks like is this is a very, very typical but simple deployment where the customer has some resources in a data center. So they order some ports from Megaport to plug into Megaport's network. And then over those ports, they provision VXCs or virtual cross connects into Azure. So this is really a very straightforward configuration of Megaport delivering an ExpressRoute circuit to a customer's data center. The bit that we're going to really look at this week is on the sort of in the middle here, just on the right-hand side. When you buy an ExpressRoute circuit from Microsoft, you order that through the Azure portal. That circuit actually contains two links, two paths, a primary and a secondary. And basically what that circuit is, what it represents, is a pair of interfaces on a pair of Microsoft switches or routers in a data center. So when you create that circuit in the Azure portal, what happens is Microsoft provisions two interfaces, one on each of two routers in a data center. And that's kind of what that circuit represents, is those two interfaces. And so what you do then is from your data center where you're connected to Megaport, you bring up a circuit across Megaport's network from your data center to that point on the edge of Microsoft's network. And that's kind of how ExpressRoute works. The complexity comes about here where the circuit connects to Microsoft. Because if you have a look in the Azure portal, when you create that ExpressRoute circuit, you'll actually see that there's multiple different peerings available on this same circuit. So on the one ExpressRoute circuit, you can do private peering and you can also do Microsoft peering. You can also see public peering here in the list, but that's kind of deprecated now. It's not actually used anymore. So realistically going forwards, you'll either use private peering and or Microsoft peering. So private peering is what allows you to create a network connection to an ExpressRoute gateway into your VNets or into your vWAN. So it's connecting to your private resources using private routing. So you've got that private path. Maybe you've got some VMs in Azure, you've got some VMs in your data center, and you want that sort of private data center type network connectivity between the two subnets. Microsoft peering, on the other hand, is how you can peer with Microsoft's public edge. So this is the public edge of Azure, which, for reasons that are probably beyond the scope of this video, just to keep in mind, is slightly different to the public edge of Office 365. So this connects to the public edge of Azure. This is where you get routes for public IP resources, things like Azure Blob Storage or public IP addresses you've got on your VMs or load balancers or things like that. Also some services like Dynamics 365 and some other bits and pieces there that use public addressing. So private peering is into your private network, your VNets. Public peering is Microsoft's public IP addresses. So it just depends which service you want to access. You can configure one or the other or both. And that's really where the core of this issue comes from. When you configure these, each of the two peerings is delivered on a different VLAN. So you can see down the bottom here in this configuration screen that the private peering is configured to be delivered on VLAN 100, and the public peering, the Microsoft peering rather, is configured to be delivered on VLAN 200. And that's really where the bulk of this situation arises. So if we go back to that image that we were looking at, but we zoom in a little bit on the ExpressRoute circuit, we kind of open up what's inside of those, what's on the ends of those lines. It's actually not a single link. That link terminates on that Microsoft device, and on that switch port, there are two different VLANs. So that switch port is actually a trunk port. So it's not a single link, and that trunk port has two VLANs configured. It may only have one, but it's always tagged, right? So even if you only use private or you only use Microsoft, it will still be tagged. So you may only have VLAN 100, for example, or VLAN 200. You might only have one VLAN, but it's still a tagged VLAN. It's not an untagged service. And so what that means is when you create a link from the port in the data center to that port on that Microsoft device, there are actually two VLANs, two tagged VLANs inside there. So what happens is if you create a VXC from your port in your data center, and that's delivered to you in the data center on VLAN 50, on the other end, on the Microsoft end, inside of that VLAN 50, there are two VLANs. So you've got VLAN 50, and inside of that VLAN 50, you've got VLAN 100 and VLAN 200. And that's what QinQ is, right? That's where you end up with having to manage this situation of having VLANs inside of other VLANs. And that's totally fine. That's supported. There's no issue with that. It does work. It's a pretty well known and well used architecture. The complexity is that not all devices support that, right? So the device that you have, the switch or router in the data center that's connected to those ports that has that VLAN 50 delivered to it, it may or may not support being able to look at VLANs within VLANs, or may not support QinQ. And even if it does, you may not want to use it, right? It may require different licensing. It may require more complex configuration. There's all kinds of reasons why a customer might not want to support QinQ, even if their hardware can do it. So how do you get around that? Let's say that you can't run QinQ. You can't accept this VLAN 50 with the VLAN 100 inside it and 200 inside it. You can't handle that on your own devices. So one option is that rather than having Megaport deliver that VXC to you as VLAN 50, you could have Megaport deliver that VXC to you as an untagged VXC. And so in that case, the VXC itself is it doesn't have a tag, and you will just see the two tags from the ExpressRoute peerings. So what you'll see on the port and what you'll have configured on your device's switch port is VLAN 100 and VLAN 200, and you won't see the outer tag because it's an untagged VXC. So this is one really straightforward way to work around that issue. The big caveat with this is that now that you have that untagged VXC connected to the port, now that that port is basically configured to send any traffic that arrives on the port down this one VXC, you can't create any other VXCs off of that port. That's the big limitation. So with it configured as an untagged VXC, you can't have another VXC, say, to AWS or Google Cloud or Oracle, or maybe an internet connection, maybe a connection to your other data center, all the other stuff that you might want to do with that port to get the most value out of it and to really leverage that network as a service functionality. You kind of can't do. That physical port is now kind of locked to only connecting to this one Azure service, this one ExpressRoute circuit, and you can't connect anything else to it because it's just going to send all the traffic to this one endpoint. So sometimes that works. Sometimes that's fine. A lot of customers do this because they don't have any other requirements. They don't need to connect anything else to the port. Maybe it's a 10 gig port and 10 gig ExpressRoute circuit, and that's all you want. So they're fine with this sort of setup. But a lot of the time, we have customers that want to have the benefits of network as a service and the ability to get the most use they can out of this port and the most flexibility, but they also don't want to do QinQ on their own device. And so that's why this Azure single peering VLAN feature was added within the Megaport configuration. So this is a third option. And what this option does is it basically moves the QinQ piece, the configuration, the sort of handling of VLANs inside of other VLANs. It moves that from the customer device into Megaport's network. So basically, Megaport is kind of managing that QinQ on your behalf and can deliver, you can have the VXC delivered to a single VLAN on the Azure side and have that delivered to you as a single VLAN on your side. So what that lets you do is use both multiple VXCs on the one port and also not have to do the QinQ on your device. So if your device doesn't support QinQ, or if you don't want to do the more complex configuration, you basically can just tick a box when you create the VXC in the Megaport portal, and you can have Megaport kind of handle the QinQ for you. And that's really popular. This is probably the most common way that we see this deployed now, because you kind of get the best of both worlds. You don't have to do the complex configuration. You don't need potentially more expensive equipment or replaced equipment, and you still get the flexibility to add other VXCs to these ports. So we'll jump into the Megaport portal just to show you what this actually looks like and how you would do it. So first off, we'll create a port. Let's put this port somewhere in Sydney. Let's say maybe Fujitsu, for example. We'll choose that we want a 10 gig port and go next and add and order. So what we've done so far is we've ordered the physical port that we're going to physically connect to in the data center where the customer physically is, right? So basically, if the customer was in this Fujitsu North Ryde data center, we'd order this physical port there so they can get a cross connect and plug in to this port. So the next step is we'll jump into the Azure portal. I've already got this ExpressRoute circuit created just because they do take a while. They take sort of 5 to 10 minutes to spin up. But basically, this is just clicking through the wizard in the portal, go to create an ExpressRoute circuit, choose the location that you want it delivered to, choose you want it delivered via Megaport. You'll see Megaport in the drop down inside the Azure portal. And that's basically how you get to this point. The most important part of this for now is the service key. So once this ExpressRoute circuit is deployed, you'll see you'll have a service key here, which you can copy. And that service key basically identifies this ExpressRoute circuit within the Azure API. So now that we've got that service key, we come back here, and on our port that we've got connected in our data center, you can go add connection and cloud. You can scroll down here to Azure and paste in the service key. Okay. So now we'll choose whether this particular link we're configuring right now is the primary or the secondary. And when we get to this part, we'll give this a name. So let's call this Azure secondary. Okay. It's picked up the rate limit for the ExpressRoute circuit from the Azure portal. So when you create the ExpressRoute circuit in the Azure portal, you'll specify the rate limit that you want, and we'll automatically pick that up and fill it in here. It doesn't have to match. There's some edge cases where you might want to have a different speed on the Megaport side compared to the Azure side. So you can do that if you want to, but the one that's pre-filled there will match what's in the Azure portal. The other thing here is the AND VLAN. So basically here we're going to choose the VLAN that we want this circuit to be delivered as. So let's choose that we want this circuit delivered on to us in the data center as VLAN 100. So by default, this section down the bottom here is disabled. By default, this will look like the first picture, right? So we've said we want this circuit delivered to us as VLAN 100. And then inside of that, Microsoft is going to tag VLANs 100 and 200 from the peerings, right? So if we jump back to the Azure portal here, we have a look at the peerings. So if we go into Azure Private, this is where that's configured, right? So for the VLAN here, we can specify whatever you like, but this is the VLAN inside of the ExpressRoute circuit. All right, so let's say that this is VLAN 100. Probably have to fill in some more details for that, but that's okay. That's basically the idea. So the VLAN that you specify in here is the VLAN of this particular peering, so of the private peering in this case. So what we'll do, if we were to deliver this as it is right now, we would have this VXC delivered to us as VLAN 100. And then inside of that VLAN 100, there would be another VLAN 100, which is what we specified in the Azure portal, right? So we would have to run QinQ on our switch, on the customer switch in the data center, to unpack that QinQ to accept VLAN 100, and then look inside of that VLAN 100, and there's another VLAN 100 tag, two VLAN tags, it's one inside of the other. If we don't want to do that, we want to just basically have Megaport deal with the hard part. So the customer device doesn't have to actually have that support for that functionality or have that additional configuration. What we can do is enable this configure single Azure peering VLAN option. And we can say that rather than delivering that service as is, delivering the sort of two tagged VLANs inside of it, we actually just want it to deliver the one that we've tagged as VLAN 100, right? So what this will do is it will pick out VLAN 100 from inside of the ExpressRoute circuit and then deliver it to us as also VLAN 100. And this is the most common configuration that we see. These don't have to match, right? So for instance, this up here could be VLAN 50, right? And then down here on the Azure side, it's VLAN 100, and we'll just transparently remap that. So if you want on the Azure portal to configure it as VLAN 100, but on your device, you want to configure it as VLAN 50, that's totally fine. But for simplicity's sake, most of the time, customers will configure these to be the same number, right? They'll say they want to pull out the peering VLAN of VLAN 100, which you've configured on the Azure portal, and deliver that to their customer switch in the data center also as VLAN 100, because that kind of gives you the best of both worlds and the most simplicity when you're trying to look after this on an ongoing basis. And that's pretty much it. So that's how that circuit will show up. So now underneath that port, we've got one VLAN delivered to it, which is VLAN 100 to Microsoft, to the Azure Edge. But specifically within that Edge port, it's specifically picking out VLAN 100 because that's what we configured for the private peering. So the simplest way to do this is you just make all the numbers match, if that makes sense, right? So in the Azure portal, you configure the peering as one VLAN. You then configure that VLAN as your AN VLAN and also as the single peering VLAN. If you put the same number in all three, it's probably going to work the way that you expect. But you're obviously, that's not a requirement. We'll remap those VLANs. It doesn't change anything on the Megaport side if you do need to. But this will give you really the most amount of flexibility and also let you simplify the configuration, I guess, on your end, on the customer side, on the switch or router that you've got in your data center. So this is definitely the most common configuration. And for sure, this is one of the most common questions or stumbling blocks that we have when customers deploy this, is this bottom section here of Azure peering VLAN, and how those VLANs in the Azure portal, with these ones here, map to the VLANs in the Megaport configuration, and then to the VLANs on their device. As I said, the simplest way is if you just use the same number for all three, assuming you're just using one peering type, so either private or Microsoft, that's the simplest way to do it. But if you do need to, you can reconfigure these however you need to. All right. So that's really the end of the main content. So let's just have a look if you had any questions on LinkedIn. So we do stream these live to LinkedIn. We also stream them live onto Zoom that you can basically register for and get a link for. We typically upload these to YouTube afterwards as well. So if you do have any questions or comments or anything, feel free to leave those on the YouTube video. We'll try and keep an eye on those. Otherwise, feel free to join these sessions going forwards, either on LinkedIn or on Zoom. We basically use that to try and drive what we do for the future videos. If there's anything you're particularly interested in, let us know. We'll try and schedule that in, or obviously feel free to reach out to your account teams if you are already a customer. Let me have a look if there's any questions we haven't got to yet. Does this work for it? Right. Okay. Yeah. So that's a good question. So basically, there's a question about how does this work with MCR? So MCR is Megaport Cloud Router. So in some situations, customers want to be able to deploy some layer 3 routing within Megaport's network, as opposed to just these point-to-point links. And typically how you would do that is with Megaport Cloud Router, which is our router product that gets deployed into a Megaport point of presence. So MCR does support QinQ, basically, and that's the short answer. You can manually configure QinQ on any interfaces of the MCR, but specifically for Azure, we have basically some automated workflows in place so that most of this all gets taken care of for you. So if you're creating that ExpressRoute connection from an MCR, it actually will use QinQ sort of behind the scenes a little bit, but it basically happens automatically. It will just automatically detect and pick up those peerings and VLANs and sub VLANs on the MCR. So you'll just see them as standard interfaces on the MCR, which can, that's another approach that can sometimes make things a little simpler as well if you'd rather handle the layer 3 part within Megaport. Okay. Yeah, I think that's pretty much all. So yeah, thanks for joining. as I said, these will be available on YouTube afterwards, and feel free to reach out and let us know what you'd like to see covered in the next ones.